So the purpose of this video is to help you visualize these different 3D shapes that we're going to be finding this volume of. So the idea, of course, is if you watch any other videos, is that we start with a shape, a region that's enclosed by certain lines and curves. In this case, we have y equals square root of x, and then we have the x-axis, and then we have this line here, which is x equals 9. And we can make a bunch of different, right now this is of course just a 2D shape, but we can make a bunch of 3D shapes by revolving them around a certain line. So for example, if we just revolve this around the x-axis, you can see that it makes a shape. And again, we're going to break that up into discs or washers, and you can see what those discs look like. That's giving you the picture of the discs that we're adding up to get the total volume. And of course, if we change the line of rotation, reset this. Oh, I want the X revolution. There we go. Go down to -2. So now if we revolve it, notice we create a kind of a bullet with a hole in the middle. And again, if we sweep, this time we're sweeping washers through. We're stacking a bunch of washers side by side to get the area. So these two that I just showed you are using the disc and washer method. Disc if it doesn't have a hole in the middle. And again, the way you tell whether it has a hole in the middle or not is by whether the region is flush up against the x-axis. And there's all kinds of cool shapes we can do this. Well, if we take this axis of rotation and go up here somewhere, like at 4, let's say. And let's move everything down a little bit so you can see. And we'll go ahead and revolve again. So this one's kind of weird. So this is like a cylinder on the outside with a funnel shaped hole on the inside. And you can see the disc again. You can see that shape of the washer sliding through it. So if we were to take this and move it right up next to that point, you see how that hole gets bigger and smaller. So again, it is helpful to kind of visualize this at first, but again, the purpose of visualizing them is to be able to see where the radius is. So in this case, notice this is a washer, so we're looking for a big radius and a little radius, and you can see the big radius goes from the line of rotation down to this outside edge, and the little radius goes basically to this blue part. And so you can tell if we just stop all this nonsense and just look at it. Once again, you can see that this line right here represents the distance from the x-axis to the shape, but I mean to the curve. And this little distance here would be the inner radius, or the small radius, and this whole line from there down to there would be the big R, or the big radius. Notice that the big radius is the same no matter where we draw it, and that makes sense when we revolve this thing. because you can see the outside edge is always the same. So notice this outer circle is always the same radius, but the inner circle gets smaller as it goes down. So and you can, of course, I can show you a different shape. So let's say x squared. And again, let's change this thing down to right there. Revolve. This is going to be huge because this thing's so far out there. Actually, maybe it's probably too big for you even to see. We'll move this into right about there. So you can see, again, there's all kinds of different cool shapes we can make based on how we pick the region and how we rotate the region. So, so then another thing that we'll do, so I'm going to close this for now and open this. Another thing we do, instead of rotating about a line, we can take a shape like a circle here, and we can basically pull cross sections out of it. So if you show the chords, so notice that every one of these chords or lines that go through the circle, they are all a different shape, right? Because they're drawn at different points in the circle. So what we're going to do is we're going to, well, let's drop the y-axis flat so you can see. So basically what we're going to do is we're going to draw a square connected to each one of those chords that we drew earlier. And notice, of course, the closer to the edge, the shorter the square, because the thing that we're drawing is a square. The height of the shape is the same as the width. So notice as the width gets wider, the height gets taller. And so right here is the biggest, this light pink one is the biggest square, and it goes on down. So, and you can see that this would create a different, distinct kind of shape. So, for example, if you just watch, here's the square as we run through, you can see it growing. And the area of this is showing the area of each square. So we're adding up those squares. And let's see what the solid looks like. It's kind of a cool shape, isn't it? So there's the solid. There's the squares, the same 4 squares we showed before. You can see how they make them. Now let's just slide a square through that solid, and you can see how. So in this case, we're not going to be adding up disc or washers. This case, we're adding up whatever shape it is that was used to create this thing. And so notice in this case, it's just a big square. So if we're trying to find the area of that square, plus a little bit of thickness, notice in this case the thickness would be dx, and you'd be multiplying the area of the square by the thickness of the square to get the volume of this. Basically, it's a really flat prism. And of course, we can do different shapes. Like, for example, here's an equilateral triangle. So you could draw some equilateral triangles. So again, the height of the triangle is based on how long that chord is in the circle. And if you sweep one equilateral triangle through there, you can see that it grows as it goes along and then gets smaller on the other side. And it's going to create a different type of solid. There's the 4 triangles in there, and then you can just see there's the shape with the triangle sweeping through it. Here's an example with semicircles. So you can different size semicircles. Of course, the diameter of the circle along here will affect, of course, how tall this is, because that's just a radius. And it'll create a cool looking solid. Isn't that cool? So then we'll show the solid and 5 of the semicircles in there, and then we can slide those semicircles along. You can see. So in this case, we're adding up a bunch of semicircles with a little bit of thickness. So hopefully this, looking at these things, being informed, will help you get a better picture when we actually, and when you go back to the other videos and try to come up with the integrals for finding these volumes. And notice right here it tells you that all you need here is the area of the semicircle. In this case it's dy, because this axis out here is the y-axis, right? So remember this is actually flat like that. So let me, yeah, see if we this is not really showing what's going on, because you can't see the 3 dimension, because the 3 dimensions come out of the thing at you, so you have to rotate this flat to see what it looks like. But remember, this is the y-axis out here that we're talking about. Okay. So that's just a little video on helping you to picture these different shapes. I'm going to show you one more before we end this. There's the third method. So we've talked about the disc and washer method, and we've talked about the one I just showed you, the cross-sectional method. So we're using cross-sections. And this next one is called the shell method. So this is going to at first look kind of like the disc and washer method, but it's different. So in this case, I'm rotating about the, here, let's reset that. I'm rotating, I'm going to change that line to right there to start with. Rotating around a y-axis. And notice instead of, before we just rotated it and you stacked up a bunch of washers to get it, but this time we're going to do what is called shells. So I'm going to show you one shell so you can try to picture that. So notice I'm taking a slice out of the middle and rotating that around, and that's how I'm creating this thing. So notice it's not a washer anymore, because remember our washers were very short little discs stacked up on top of each other. This is actually a very tall washer, I guess you could say. And that's why we call it a shell, and they're nestled inside each other. So we did a different one. Here's a different one. You can see that it would be a shorter shell, because the height of the shell is being determined by this blue line here. And if we do another one, we can move this in even further. And once again, it's going to be even shorter shell. Now if we show all of them, so again, it produces the same shape of, if we roll around if we spin the circle, or the outside edge is just a big cylinder and the inside it looks kind of like a funnel. You can't see the actual shape because we're showing the shells, but this is, if we let these shells get smaller and smaller. In fact, let's do that. Let's make our end get bigger. Let's go 20. Reset. And show all cells this time. So now notice the shells are the thickness is smaller. And in this case, that's where the dy or dx comes from, is because you're making the thickness of each of the shell smaller. And notice as we add more and more shells to this thing, we get smaller and smaller thicknesses, and it becomes more of a, of course you can't really see it now because it's so black, but we get a you can see the shape is looking more and more like what it is if you could see these rectangles, but they kind of blend into each other because there's too many of them. But let's just do one of them again. So you can see how skinny that little shell is. So the change, in this case, this would be a change in x because we're talking about the thickness of that shell. And again, if we move x down a little bit, say here, do it again. Again, it's the same type of shell, but it's shorter now. And if we go the other way, now it's a taller shell. So you can see these shells are nestled inside of each other. And they add up, they combine to give you the total volume of the shape. So notice in this case, I could have stacked donuts here too, or washers. I could have stacked them up this way, or I could use these shell methods. So the shell method and the washer method can often be used on the same shape. Okay. So hopefully that helps you visualize what's going on.